Hello everyone, welcome to this video. Let's start with the LTC AIIMS Chemistry Weekend Test Paper Solution. Here's question number 1. Total energy of electron in third orbit of helium ion would be. So total energy is equal to the energy of electron and it is equal to minus 13.6 Z square by N square. Is that clear, guys? So total energy of electron in third orbit. So the value of N is 3 and for helium ion Z is equal to 2. So substitute the values, you will find it. The answer will be minus 6.04. Magnetic quantum number of an electron is minus 2. Which among the following statements is incorrect? Principal quantum number can be 3. Yes, that is correct. It could be 3. Azimuthal quantum number can be 2. Yes, L value can be 2. Electron can be in s orbital. No, because for L is equal to 2, the value of Ml will be minus 2, minus 1, 0, plus 1 and plus 2. So L is equal to 2 means we are talking about d subshell here. Electron cannot be present in s orbital. Right? So this is the incorrect statement. Uncertainty in finding position and velocity. So as per the Heisenberg uncertainty principle, delta x into delta v is greater than or equal to h upon 4 pi m, right? So alpha particle, proton, neutron and electron. The heaviest particle is alpha particle, mass is maximum. So the product of uncertainties in position and velocity, this will be minimum. So alpha particle is the correct answer. In the orbitals given below, minimum number of radial nodes, guys, it is n minus L minus 1, right? So you can calculate for D, L value is 2, for F, L value is 3, for S, L value is 0, for P, L value is 1. So you can calculate, it will come out to be minimum for 5F. Number of protons, neutrons and electrons. Okay, so the atomic number is 19, the mass number is 234. So number of protons is 90, and because the species is neutral, number of electrons will also be 90, and number of neutrons will be mass number, which is 234, minus atomic number, which is 90. So this will come out to be 144. So this is the correct answer. Wavelength of electromagnetic radiation having wave number is reciprocal of wavelength, guys. Okay, so wavelength will be 1 upon wave number, right? So this will be a correct answer because it is millimicron, which is basically 10 raised to minus 9 meter, that is nanometer, right? Maximum number of electrons in 3D orbital. Obviously, every orbital can have only 2 electrons, maximum of 2 electrons. One will have up spin and one will have down spin. So S is equal to plus half, there is only 1 electron. Two matter waves A and B have the same magnitude of wavelength. So lambda is equal to h by mv as per the de Broglie's equation. Because they have the same wavelength, they will have the same value of h by mv, or I can say they will have the same value of ma va is equal to mb vb, right? Linear momentum will be same for both of them. So if mass of A is half that of mass of B, right? So MA divided by MB is equal to VB divided by VA. So if mass of A is half that of mass B, so you can substitute the values here and you will find out that it is half that of A. That's the correct answer. Wavelength of quantum of radiation is 310 nanometer. Number of quanta. So you'll use Planck's equation, E is equal to NhC by lambda, right? So number of photons will be energy is 100 joule, wavelength is 310 into 10 raised to minus 9 meter divided by the value of Hc. You can use the value 2 into 10 raised to minus 25 in SI units. So you'll see this will come out to be 1.56 into 10 raised to power 20 approximately. So that is the correct answer. Which of the following sets of quantum numbers is not allowed for n is equal to 2, L is equal to 1, and remember guys, the values of ml are minus L to plus L. So for L is equal to 1, ml is equal to minus 2 is not possible. So this set is not possible, it becomes the correct answer. Wavelength of the particle, again de Broglie, it is lambda is equal to h by mv. The value of Planck's constant is 6.626 into 10 raised to minus 34 joule second divided by the mass of the electron is 10 raised to minus 25 kg. All right. And the velocity of the particle is 1 by 300th of the velocity of light. So which is basically 3 into 10 to the power 8. And I'll divide it by 300, that is multiplied here. So you will work this out. You will find out that the answer is this. Okay. Enthalpies of combustion of graphite. Okay, so graphite enthalpy of combustion, it is CO2. This is given to be how much? The enthalpies of combustion of graphite is minus 393, right? For hydrogen, it is minus 286. For ethylene, it is minus 1413. So the enthalpy of formation of ethylene. So ethylene, guys, it is C2H4, and so this will be 2 of carbon graphite plus 2 of hydrogen, right? Now remember, whenever enthalpies of combustion are given, then the enthalpy of a reaction is enthalpies of reactants minus enthalpies of products always. Okay, so 2 multiplied by the enthalpy of combustion of graphite, which is given to be minus 393, plus 2 multiplied by the enthalpy of combustion of hydrogen, which is given to be minus 286, and we will subtract from this the enthalpy of combustion of ethylene, right, which is given to be minus 1413. So the correct answer, you will find out, it will come out to be plus 55. Enthalpy of fusion of ice is given, and we will take the temperature to be the melting point of ice, which is 273 Kelvin approximately. So the entropy of fusion, guys, it is delta H by T. So basically it is 6000 joule per mole divided by 273 Kelvin. So when you will calculate it, it will come out to be approximately 21.97. You have to calculate the heat of formation of SO3. So heat of formation of SO3, guys, it is S plus 3 by 2 O2. It gives you SO3, right? So I have to make this equation from the given these two equations. So sulfur comes in the first equation. I'll take it as it is. So the enthalpy of formation of SO3 will be minus 300. And I need SO3 on the product side. So what I will do, I will reverse this equation and I will multiply it by half, right, so that the coefficient 2 will be gone and it will change its side. So the same change will be reflected in enthalpy. So this will be plus 189 becomes minus 189 multiplied by half. So you will see this will come out to be minus 394.5. Enthalpy of trimerization of ethine. Okay, so trimerization of ethine will be the combination of 3 molecules of ethine to give you benzene. This value is minus x. Enthalpy of hydrogenation of benzene. Benzene will consume 3 molecules of hydrogen to give you cyclohexane. For this reaction, the enthalpy change is given to be minus y. And the question is enthalpy change for the formation of 1 mole of cyclohexane from ethine. Okay, so this will require 3 molecules of ethine as well as 3 molecules of hydrogen. And if you observe that this third equation can be obtained upon simple addition of the first and second equation, right? So 3 molecules of ethine plus 3 molecules of hydrogen will give you 1 molecule of hexane. So the enthalpy change in the third equation will simply be the sum of these, which is minus x plus minus y. So basically minus x plus y. All right, so that is the correct answer. Standard enthalpies of formation are given, and you have to find out the combustion of ethylene, right? So, acetylene, sorry. So this will be C2H2 plus combustion is O2. It will give you 2CO2 plus H2O, right? So this is 5 by 2. So guys, remember, whenever enthalpy of formation are given, you have to do enthalpy of formation of products minus reactants. So this will be 2 multiplied by that of carbon dioxide, which is given to be minus 94, plus the value of water, which is given to be minus 68, and minus the enthalpy of formation for oxygen gas is 0 by definition, and then we are left with the acetylene, right? So which is plus 61 basically. So if you will solve it, you will find out the answer to be minus 317. Okay. Enthalpy of sublimation of iodine. So sublimation is the conversion of solid to gas. This value is given 63. And then enthalpy of atomization of iodine gas, right? So this will be I2 gas to give you 2I of gas, right? Atomization, this is 157. And the question is, you have to find out this enthalpy change, 2I gas to I2 solid, right? Now, if you observe, I have to reverse the second equation, right? So the enthalpy change will be reversed, minus 157. And I have to iodine solid. I have to reverse equation 1 as well, right? So this will become minus 63. So this will come out to be minus 220. The process which is accompanied with decrease in entropy is condensation, because in condensation gas converts to liquid, right? So entropy will decrease. Enthalpy of solution of MCl2 solid, it is some compound, and when we dissolve it, the enthalpy of solution will be M2 plus aqueous plus 2 chloride aqueous, right? This is given to be how much, guys? Minus 108. Now enthalpy of solution of MCl2.6H2 is given, and the enthalpy of hydration of MCl2 into its hexahydrate is asked. So it is clear that this hydration, this solution involves two steps. First, the conversion of anhydrous MCl2 into the hexahydrate MCl2.6H2, and later the hydration, the solvation of this hexahydrate into aqueous form, right? So MCl2 to MCl2.6H2O, enthalpy of hydration of this is asked. This is X. Let us say it is X, and the hydration of MCl2.6H2O, it is given to be minus 81 by Hess's law. Enthalpy is a state function, so minus 108 equals X plus minus 81, right? So you work it out, you'll find out that it is minus 27 kilojoule. It is a thermochemical equation, correct? It is correctly represented. Enthalpy change denotes the standard enthalpy of formation. No, please read the definition of enthalpy of formation. We can only define it for the formation of 1 mole of compound, but in this case, 2 moles of compound are formed, right? So this is not correct. All the other statements are correct. Standard enthalpy of formation is 0 for phosphorus, white phosphorus, right? It is by convention. For carbon, it is graphite. For sulfur, it is alpha, rhombic form. For bromine, it is liquid. Enthalpy of combustion of diamond. So we are burning diamond. And it is releasing minus 94.5, right? So it is releasing 94.5 kilocalorie of heat. Enthalpy of combustion of graphite, it involves the release of 94 kilocalorie of energy. Now you want to convert 1 mole of diamond into graphite. So while we are converting 1 mole of diamond into graphite, right? So I will take the diamond as it is. It's worth taking, and I will revert the second equation. So minus 94 will become plus 94. So basically it will be minus 0.5 kilocalorie, which is basically minus 500 calorie, right? Enthalpy of atomization is always positive, yes, because it involves the breaking of bonds. And enthalpy of solution can be positive and negative. It depends upon the relative magnitudes of the enthalpy of hydration and the lattice enthalpy. So both statements are correct. All the following statements are different forms of second law of thermodynamics except the fourth statement, because that is actually equivalent to the first law of thermodynamics, right? The law of conservation of energy. In SN1, the reactivity is proportional to the carbocation stability, and tertiary carbocations are most stable, so this compound is most reactive. Reactivity towards SN2, reaction of the following compound is this. Yes, because the first compound is primary, whereas the second compound is secondary, in which the steric hindrance is more. The rate of SN2 reaction depends on the steric hindrance. Yes, it is inversely proportional to the steric hindrance, so both statements are correct. Most reactive alkali halide toward SN2 reaction. Smaller the alkali halide, more reactive it will be, right? So we have two options, CH3Br and CH3I, and because iodide is a better leaving group than bromide ions, so CH3I will be in fact, it is the most reactive compound towards SN2 reaction. You have to identify the correct statement regarding SN1. It proceeds by a one-step mechanism. No. First, the alkali halide dissociates to give carbocation and then nucleophile attacks, right? It involves carbocation formation. Yes. It is favored in polar protic solvents like water, acetic acid, right? Percentage of retention product is more. No. The percentage of inversion product is more because of the intimate ion pair formation. So the only correct statement is B. The following halogen compound undergoes racemization, so chiral carbon should be present. You can check that these compounds do not have a chiral carbon, right? So there is a chiral carbon here, methyl, bromine, hydrogen, and ethyl. So racemization will occur in this compound. Which one of the compound is least reactive? Yes, halogenes are least reactive because of a variety of reasons. The carbon is sp2 hybridized, there is partial double bond character, the carbocation is unstable. So this compound is least reactive. Yes, so you can see from the product here that iodide ion actually attack the methyl group, the lower alkyl group. So this reaction must have occurred via SN2 mechanism. All SN1 reactions involve racemization. No, it depends upon whether the substrate is chiral or not. All SN2 reactions proceed with the formation of transition state. Yes, because all SN2 reactions are elementary. They occur in one step, and every elementary reaction occurs through the formation of a transition state. So statement 1 is incorrect and statement 2 is correct. Okay, guys. The rate of reactivity is maximum when X, Y, Z are. Okay, so this is chloride is being replaced by hydroxide. So this is SNAR, substitution nucleophilic aromatic. The intermediate is an aromatic, is a carb anion, right? So we should have electron withdrawing group on ortho para position, and NO2 is the most powerful electron withdrawing group here. So this situation will give rise to the formation of most stable intermediate. So this will be the maximum reactivity. Correct decreasing order of reactivity towards SN2. So N-butyl is primary, isobutyl is primary, but there is a bit of steric hindrance, right? But still more reactive than the other compounds. So this is isobutyl bromide, it's still primary, but there is a bit of methyl group here. Okay. Then tertiary and secondary butyl bromide, obviously tertiary will be less reactive. So this will be the order, right? So this is a special reaction. It occurs through the formation of benzene. And how do we know that? There is no electron withdrawing group on the halorine. The nucleophile is a strong base, right? And this is the nucleophilic substitution. So either it is SNAR or it is benzene mechanism. Here, because there is no electron withdrawing group, it will go via benzene mechanism. Hund's rule and Pauli's exclusion principle are violated here because both electrons cannot have the same spin. Pauli's and the unpaired electron should have the same spin. Hund's rule, right? In the line spectra of multi-electron atoms, some lines actually occur in doublets and triplets. Yes, multiplets do occur. Extra stability of completely filled and half-filled subshell is due to larger exchange energy. Yes, correct. So both statements are correct. Which of the following statements about quantum mechanical model of atom is false? Schrodinger wave equation actually cannot be solved for multi-electron system because of the repulsion term between different electrons, right? So all of the statements are correct. Identify the correct statement. PZ orbital has XY plane, yes, perpendicular. DXZ orbital, yes, it will have XY and YZ because XZ is the orbital plane. So YZ and XY, they will be nodal planes. According to quantum mechanical model of electron behaves like both wave and particle. So this is incorrect. And the 1s and 2s orbital, they have a same shape but different sizes, right? So this is also incorrect. So correct statements are A and B. Bond enthalpy are when bond enthalpy values are given, guys, you have to do the bond enthalpies of reactants minus bond enthalpies of product. So standard enthalpy of formation, it is half H2 plus half Cl2 gives HCl, right? So enthalpy change in this reaction will be half of the bond enthalpy of H2, which is 436, plus half of the bond enthalpy of chlorine, which is given to be 243, minus the bond enthalpy of HCl, which is 432.5. All right. So this will give you the correct answer. This will come out to be minus 93. For the same amount of heat absorbed reversible and isothermally, the increase in randomness at low temperature is more than at higher temperature. Yes, because entropy change is Q reversible by T. So entropy change depends inversely on the temperature. Lower the temperature, greater will be the magnitude in entropy change. For a spontaneous process, total entropy change should be positive. The entropy of the system may be positive or negative. It depends upon the process, right? So statement 1 is correct, statement 2 is not. Enthalpy of combustion of rhombic sulfur is S8 when you burn it. So it will give you 8 molecules of sulfur dioxide, the major combustion product. Enthalpy of formation of sulfur dioxide, yes, we just don't want 8. So we will divide this value by 8. So this is the correct answer. Enthalpy of solution of NaCl is 4 kilojoule per mole. So yes, that is 4 kilojoule per mole. Now enthalpy of solution is lattice plus hydration. Lattice is 788, guys. And hydration is how much? The hydration enthalpy of NaCl, actually the ratio is given 6 is to 5. So let us call them 6x and 5x. So it will be 11x, right? And remember, hydration enthalpy is negative, right? So you solve this equation, you find out x, and your answer will be 6x, right? So that will be approximately minus 427.6. Enthalpy of combustion of methane. Best fuel is they're asking about the calorific value, the amount of energy released by the combustion of 1 gram substance, and the substance which gives maximum amount of heat will be the best fuel, right? So for instance, for methane, the calorific value will be minus 890 divided by the molar mass of methane, which is 16. Similarly, for ethane, it will be minus 1560 divided by the molar mass, which is 30. So you do with all of them, enthalpy of combustion divided by molar mass, the maximum value will be corresponding to the best fuel. So this will come out to be methane, the most saturated here. Consider the reaction. Just observe this reaction carefully. The nucleophile is very strong, cyanide, which is usually the case in SN2 reaction. and there's no carbocation rearrangement, right? We could have had a carbocation rearrangement primary to secondary, but no. So this reaction definitely didn't occur by SN1, it occurred by SN2. And if you notice that these are polar protic solvents which are favored in SN1 reaction, and this is dimethyl formamide. It is a typical solvent used in SN2 reaction. So this is the correct answer. Correct increasing order of reactivity towards SN1. Yes, this is primary benzyl. This is benzyl and two phenyl groups. This is two phenyl group and one methyl group, and this is triphenyl methyl carbocation. It will give. So yes, they are in the correct increasing order of stability. So A, B, C, D. Yes, so if you again observe carefully, iodide actually attacked here, and we know that as compared to methyl, benzyl carbocation is much more stable. So the reaction occurred via SN1 mechanism. Here, you are converting alcohol to haloalkane, which is a nucleophilic substitution reaction, and because it is aqueous HCl, so SN1 mechanism is preferred, and benzyl carbocation. So we need to have some electron donating group, so which is CH3 here. So this is the answer. KCN is strong nucleophile DMF, so it is SN2 reaction. Bromine will not attack, this will attack. So you will see that this is the correct answer. It is given that the reaction is taking place via SN1 mechanism. So when you remove this bromide, you will have a carbocation here, and which will immediately undergo 1,2-methyl shift to give you a more stable carbocation. So hydroxide will then attack on the more stable tertiary carbocation. This will be the correct answer, guys. Okay. So that's all from my side. Thank you, guys.